Welcome to the first webinar in our Mathcad series. Thank you all for joining today. The plan for today's webinar is as follows. For the first 20 to 25 minutes, I'll demonstrate some Mathcad basics, and during this time we'll have everyone on mute so that I can deliver the content without interruption. We'll monitor the chat for questions during this time, so please use the chat to ask questions as they occur to you. Afterward, I'll do my best to address them. The remainder of the hour will be dedicated to your questions, and I've also prepared several demonstration worksheets that I can share during this time to illustrate how the functions in the initial presentation can be applied in engineering calculations. With that brief introduction, let's get started. Mathcad Prime uses the Microsoft Fluid Ribbon interface. Across the top are tabs for math, input-output, functions, matrices, tables, plots, formatting, calculation, document, and getting started. It seems logical to begin on the Getting Started tab. On this tab, the ribbon is divided into help resources, connections to the Mathcad community, tech support, and learning. The help resources include an icon for tutorials as well as for searchable help. I will click on the help icon, and the help dialog box opens up. This dialog enables navigation to the Getting Started tutorials. If I click here on tutorials, they will open up. It also has links to the documentation for Mathcad Prime and the many functions that are available. Today we're going to learn about operators. So let's left click on the operators section of the book, and I'm going to scroll down through the list, and I'm going to left click on calculus operators. And that's going to open up another list, and I'm going to go down and I'm going to identify the integral operator, and I will left click on that, and the help comes up. There's a nice table at the top, and I can see that the operator for the integral looks like the standard mathematical integral symbol, and I get a basic description of the integral. I can also see the hotkey or the keyboard shortcut, Control-Shift-I. Let me close this window. I've left click onto the Mathcad worksheet to place my insertion point, and I'm going to use that hotkey that I just learned, Control-Shift-I, to insert an integral symbol. In the placeholder beneath this symbol, I'm going to type a 0. Above, I'm going to type a 2. I'm going to choose a really simple function. I'm going to choose a constant function, 3, and I'm going to integrate with respect to x. I can now press the equal sign to evaluate my integral, and I get the result of 6. Mathcad is telling me through this evaluation of a definite integral that the area under the line y equals 3 between 0 and 2 is 6. For anyone on the line who doesn't speak calculus, let's make a plot. I'm going to click on plots, and now that I'm on the plots ribbon, I'm going to go over to insert plot. I'm going to left click on the insert plot icon to open a list of plots, and I'm going to scroll down to choose an XY plot. When the plot opens up, I'll scroll down in my window a little bit so I can see the whole plot. When I click down here, this is my independent variable, or my x-axis, it says above it. And so I'm going to put x on my x-axis, and I'll click over here. This is my y-axis. It tells me that above it, and I will click 3. So now I have my function defined and my variable defined, and if I click out, I get a plot of that function. If I want to edit this, I can go over here on my x-axis, and I can change my minimum to 0, and I can change my maximum. I'll go to the last value of 2. And the other editable value on this list is the increment here, or the first tick mark. I'm going to change that to 1. And now I can see that between 0 and 2, this function, there's a rectangle here. I guess maybe if I change that, it'll make it even more clear that we have a 3 by 2 rectangle, so the area under this curve between 0 and 2 has to be 6. Okay. So there's a very simple demonstration. Let me drag this down a little bit. Okay, we've inserted a math region, we've inserted a plot. I can go back, I can edit the integral, click inside of there, hit backspace to delete the 3, type x. So now I'm going to integrate x with respect to x from 0 to 2. I'm going to go over here and change my dependent variable. I'll delete the 3 and make that change to x. And I can see now the integral here is beneath the curve. I have kind of a triangular region, or exactly a triangle region, with an area of 2. Going back, I'm going to click back now on the Getting Started tab. Alright, and we can see again there's my help window, which is a great place to start any type of problem that you need to solve. And I'm going to encourage you, just like I just did, to pull up something that I need to do and test it out directly in Mathcad. Experiment with using Mathcad by exploring the help. And I think you're going to be really pleased by what you're able to accomplish through trial and error explanation. And as you've seen, the time required to look things up can be offset oftentimes by the speed which with Mathcad will perform common tasks like making a plot. So let's learn how to use some of the basic capabilities on Mathcad's Math ribbon to use Mathcad as a calculator. The Math ribbon includes icons for region types, operators and symbols, styles, units, and a copy and paste clipboard. The Math ribbon's design accomplishes two important things. It contains most of the capabilities required for basic engineering calculations, and it presents these capabilities in a way so that it is easy to use. The help and the tutorials are often unnecessary. To begin with a clean worksheet, I will left click on the Mathcad menu and I'll click New. As I click around on my worksheet, notice that the blue plus sign snaps to the grid. The Mathcad worksheet grid is available to support the alignment of regions, and the plus sign indicates the current insertion point. I've placed the insertion point in the top left corner of the worksheet, and on the Math ribbon there are 5 different types of regions: Math, Solve Block, Text Block, Text Box, and Image. For the moment, we're going to just use Math regions, so I can go up and I can insert a Math region by clicking on the Math icon in the Regions group. When I do, a Math region appears on the worksheet with a blue insertion cursor. In this region I can type some numerical expression like 5 plus 17 minus 12 minus negative 9, and I can evaluate it by typing the equal sign. Mathcad performs the calculation using the order of operations and it produces the result. Now I have an evaluated Math region on my worksheet. Note that like all Mathcad regions, it is possible to drag and drop this region anywhere in the document. It is important to understand this. On a Mathcad worksheet, all of the regions float. By its nature, Mathcad functions a little bit differently than when you're working in a word processor. Now I'm going to create another Math region. Note that when I hover over the Math icon on the ribbon, a help box appears here with a brief explanation and the hotkey shortcut, which in this case is Control-Shift-M. You can also use this the hotkey to create the Math region, but for visibility I'm going to click on the icon again. And let's use some more interesting operators this time. If I left click on operators, I get a palette with many different types of operators organized into regions. There are algebra operators, calculus operators, comparison operators, definition and evaluation, engineering, vector and matrix, and so on. I'm going to hover over the square root and nth root operator. When I do that, again a help box appears with an explanation and the shortcut key, which in this case is a backslash, in parentheses. When I left click on the square root symbol, a Math region appears with the square root operator in it. Note that the operator has placeholders for the expression and for the degree. Let's calculate the cube root of 343. I'll left click on the degree and I'll type a 3, and now I can go up to the operator and I'm going to go down and I'm going to choose evaluation from the definition and evaluation section. Left click on that and I get my result of 7. So you can see it's quite easy to type basic mathematical expressions in a Mathcad worksheet. One of the things we have to be careful of though is that we're doing things in the correct region type. Right? If I were to create a text box and type this expression, Mathcad's math engine would not be able to evaluate it. Right? So we have to put mathematics that we want Mathcad to operate on in Math region. Now, I've shown you a couple of different ways of inserting a Math region. Now I'm going to show you a third. You can just start typing. If I type the number 12, I've now entered into a Math region, and the reason for this is that Math region is the default region type in a Mathcad worksheet. So I can go in and I can immediately start typing an expression, and Mathcad is going to assume that I'm inputting a mathematical expression. And as I'm doing this, the only keys I'm really using at this point are the number keys and the arrow keys. I'm going to go over and choose an exponent, the caret being exponentiation, and I have 12 times the quantity 1 minus 5 squared, and I can evaluate that, and I get the result 192. If I meant to say cubed, I can go and I can click on that, backspace 3 minus 768. Typing another expression. This time I want to start with a fraction, so I'm going to choose the division bar. I have 4 over 3, right? Anytime you click out of a math region, you can just click right back into it. I'm going to use a right arrow, add an operator for multiplication. Now I'm going to add something new. I'm going to add a constant. In this case, I'm going to add the constant pi, and then I'm going to multiply by the quantity 6 raised to the third power. I can evaluate this, and I get the result 944.779. And if I want, I can drag this over here. Right? Again, right now we're using the operators. Part of that is for you to see that they're there. Part of it is to illustrate. You obviously can't see my keyboard if I'm typing on my keyboard. One thing to note is that when you're in a math region, there are no character spaces. Right now I'm going to type the space bar on my keyboard. And notice what happens when I'm typing the space bar once, twice, 3 times, 4 times. The space bar is performing a scoping function, and it's going through and selecting different pieces based on order of operations as I'm scoping through the math region. In general, we've got this really nice environment for typing in mathematical expressions, but there are a couple things to think about. One is that you have to be very careful to always put math in math regions if you want to evaluate it. Another is that because the math region is the default region, if I wanted to go in and do something like type the answer is, if I just start typing THE and hit space to continue typing, I select and deselect the variable name the because I've began typing without inserting a text block or a text box. And notice also that when I'm in this math region, all of the other region types are not allowed. And similarly, if I click on the worksheet, I can now insert a text box, but when I'm in there, I can't insert a math region or a solve block. So regions content needs to be put in type-specific regions, and this is something that catches people up early on. If I wanted this to be in a text box, all I need to do is go up here and delete the region, and then click the text box and say the answer is. Although Mathcad can be used as a simple calculator, it is much more than that. Mathcad actually has 2 different math engines, one for numerical algorithms and one for symbolic algorithms. Each engine requires its own symbolic operator. Many people think about this in relation to Mathcad's multiple equal signs. And I can find these equal signs under the operators palette. If I go down to definition and evaluation, Mathcad has different symbols for assignment, for numerical evaluation, and for symbolic evaluation. I'm going to create a new worksheet, and we'll do a simple demonstration of the use of these 3 different evaluation symbols. First I'm going to go up and I'll pull up an assignment, and if I assign to the variable a the value 7, and now I'll click over in my worksheet and I will again insert an assignment operator and assign to b the value 5. I can evaluate the square root of the sum of a and b. So I'll go in and I will choose a square root symbol, and then I will type a plus b, and I'll evaluate that numerically. And the sum of the reciprocals of a and b, let's use the division bar, 1 divided by a, I'll right arrow, plus, again I'll insert my operator, 1 divided by b, and I'll evaluate that numerically. There we are. And now I'll go in and I'll just type those again quickly. Square root a plus b. But this time I'm going to evaluate symbolically. And I'll do the same here. I'm going to type 1, and then I'll insert divided by a plus 1 divided by b, and now I'll go and I'll choose the symbolic evaluation. What this demonstrates is the operation of the two different engines. Here I get a numeric result, here I get a symbolic result or an exact result for the square root of a plus b. Here I get a numeric result for the sum of the reciprocals, here I get a symbolic result. And now in my worksheet, a and b are variables or parameters. So I can go in and I can edit a. And when I click back on my worksheet, everything updates. And I can edit b. And when I click back on my worksheet, everything updates. And so you can see how I can use these as parameters throughout the worksheet, and all of the math regions are updating automatically. Mathcad Prime is a computational document environment designed for detailed and fluid communication. And once you've mastered assignment and evaluation to define variables and perform calculations like we've shown here in this example, it's time to learn how to introduce text and image regions to better communicate context and intent. To begin, I'm going to create a new worksheet. And let's suppose for this example that I'm an engineer for Kitchen Corp and I'm designing a ventilation hood for a grill. And I've created a concept sketch in PTC Creo, and I want to calculate the volume of the hood. I can insert an image into my worksheet by clicking to locate my insertion point and then going up and selecting the image icon. And then I want to browse for my image, so I'll click on that. I've got it set up so I go right to the correct location, and I'm going to open that up, and now the image pops into my worksheet. And I can resize that. If I grab the midpoint of either the right side or the bottom, I can resize my image. When I get to an edge, I can drag it, and maybe I'll expand it just a little bit so I can see the numbers a little bit better. And then I have an image that I can work from in my calculations. When I'm making a worksheet, I always like to insert a text block that is the title of it, and also I usually use text blocks at the beginning of a new section within a document. And I'm going to give this a title of Volume Calculation for Ventilation Hood Concept, and underneath I'm going to type a note that all the measurements are in centimeters. I'll put that in parentheses. And then I'm going to go down here and I'm going to insert those measurements into my worksheet. And I've got 4 different measurements that I can see on my sketch here. The first one is I'll put in the height of the base. And so I'm going to type H, and then I'll go up to the operators and see there's definition. And I'm going to make a definition here. The height of the base right here is 125. Then I have 2 bases. Base 1, and I'll use the hotkey colon. Base 1 is assigned 250. Base 2 is the smaller base. Base 2 is assigned 100. And then the height of the prism, I'll make large H, is assigned using the colon 200. And these are all in centimeters, but these are my measurements. I'm going to click above that list, and I'm going to go up and I'm going to insert a text box, and I'm going to list those as my measurements. And then I'm going to go down and I'm going to type up my calculations. Because I'll start by creating the text box for calculations, and my calculations are going to be for the area. So I've typed area, colon, and now I'm going to put in a formula. I'm going to put the height divided by 2 times the sum of the bases. So let me look in here. I'm going to do height divided by 2, so I'll use division. H over 2, and I'll right arrow and I'll insert multiplication, and then I'm going to insert a parentheses or type a parentheses, and then I can add. Once I have those 2 bases added, I'm going to hit return, and now I can evaluate this variable by saying area equals. I could have just typed the equal sign, but now I know my area. My volume formula is very simple because it's just going to be my base, my area, times the height of the overall prism, and then I can evaluate that by typing equals. So there I have my two results, and I probably want to go back up here and click here and add a text box that says is the height of the base, and here I'll add another one that says is the height of the prism. And now I've got my worksheet, my calculation documented in an engineering worksheet. One of the most powerful capabilities computer users have acquired over the last 20 years is the ability to easily format documents for expression and readability. Mathcad offers users a number of easy-to-use formatting capabilities. In order to demonstrate these, I'm going to take this existing worksheet and pretty it up a little bit. At present, all the mathematics appears in italic Times New Roman font, and all of the text is appearing in Tahoma font, and all the text is black. What I'm going to do in this case is I'm going to first click in a text block and then click on the formatting ribbon. Over here on the left we have all of the tools for formatting text. I'm going to select, using my mouse, everything in this title block that I created, and I'm going to center it. And now I can click in there to deselect, select the top line and bold it, and maybe I want my subtitle or my note to appear in the same color as the measurements on my image, and so I'll change that color so I get a little bit of formatting there. I can select more than one thing at a time, so I'm going to hit Control, hold down the Control key, and I'm going to click on Measurements and Calculations. Now both of those whole regions are selected, and I can underline all the text in both of those regions at the same time. And then as I scroll down and I look, things look pretty good. Maybe I'm not so happy with these numbers and the format they're in, so I can click on Area, click on the numerical result there, and I can go over here where I can change the numerical format and change that from general to decimal, and I'll do the same for the volume. And so now I see both of my results as decimals. So there, that looks much prettier. It's easier to find the information that I need. Now, if any of you've used Mathcad before, you might be wondering why I created this entire worksheet without using any of Mathcad's unit capabilities. Right, Mathcad has units built right into the math ribbon, and the units are actually mathematical quantities. Well, it's not too late, so let's go in and do that. I'm going to edit my math regions in my measurements, and I'll go in and I'll put the units in. So I'll add centimeters there and centimeters here, and you notice that these results are automatically updating, and right now I've got errors because I've got unit incompatibility. But once I'm finished adding all the units in, Mathcad is going to produce the results using its default units, which are metric, but I can change it to any appropriate units that I want. So in this case, maybe I want my area in square feet, so I've deleted the unit meter, and I'm going to change that to feet squared. I'll click in this region, I'll backspace to delete the unit liters, and I'll type feet, and I'm going to choose to insert an exponent because I have to use cubic units, and I'll change that to feet cubed. And there we are. So in a Mathcad worksheet here, you're seeing that these units are actually mathematical quantities. They're not decorations. Best practice, I would have used the units directly from the start, but in this case I added them in at the end just so we could focus entirely on units and see how that changed the appearance of the worksheet. And the units are obviously appearing in the standard color, which I can change on the formatting tab if I desire by going over and changing unit and changing it from blue to, say, red in this case.